Welcome everyone to this series on Calico Network Policy Introduction. Let's first look at the agenda. We're going to start off with an introduction to the Kubernetes networking model and understand why you would want to consider implementing network policies to secure workload communications in a Kubernetes cluster. We will next look at the anatomy of a Calico policy, understand the structure and the constructs that make up a Calico policy. Calico policies tend to be quite powerful, quite flexible. We're going to start with a basic introduction and then look at three policy examples. First off, we're going to look at a Denialist policy, next a namespace isolation policy, and finally a workload isolation policy. And the idea behind going through these examples is so that you have somewhat of a mental model that you can refer back to as you consider developing policies for your environments. And these three policies tend to be the most common policy patterns. Okay. And we will walk through these policy and the policy implementations in a actual environment that you could refer back to as well. Okay. All right. So starting off with the Kubernetes networking model. Now, the model stipulates that pods can communicate with all other pods on any other node without the requirement for network address translation. Okay. Essentially, we're talking about a flat network where every pod in the cluster can talk to every other pod in the cluster. Agents on a node such as systemd and kubelet can communicate with all pods on that node. And the CNI or the container network interface plugins are responsible for implementing the underlying networking for the cluster as well as providing the security policy engine to implement the policies in a data plane. It could be a data plane such as IP tables, Windows HNS, or eBPF. Okay, and Calico being one such policy engine. Okay. All right. So if you look at the characteristics of a policy in Kubernetes, policies are label based. They are declarative and they are dynamic. Okay. So we use labels to identify the workloads that we want to secure using policies. So policies are workload identity based. They are declarative in that if you compare Kubernetes networking policies to that of, let's say, a firewall policy, firewall policies tend to be imperative. Typically, you have a source, a destination, and a service port, and you reference these as in you reference the network flow as you protect or permit traffic using a firewall. In Kubernetes, it's a bit different. You have a declarative policy language. The policy implementation is taken care of by the CNI. However, you're exposed to this declarative language that you could use to define your security intentions. And we will look at that using the example subsequently. And policies tend to be dynamic. Once you've defined a policy, the policy scales with your workloads. As your workloads scale, every workload receives the intended policy. And as they scale down, policies are taken off. And it follows the workload regardless of where a workload is scheduled in the cluster. You could expect the policy to be present. Okay, so it's dynamic in that sense. Okay. All right. Now let's look at the anatomy of a Calico network policy. Okay. Now we first start off by defining the scope of a policy. Calico has two types of policies. We have namespace scope policies, which are referred to as network policies, and policies with a global scope, which are referred to as global network policies. Okay. A namespace scope policy applies to endpoints within a given namespace. Okay. And a global policy or a global network policy can cut across namespaces, as in it can apply to endpoints within one or more namespaces. Okay. So you define the scope to select a target set of endpoints to which a given policy applies. Okay. So within a given scope, and a scope could be a namespace or it could be multiple namespaces if it's a global network policy. Within a given scope, you could use selectors to further narrow down or focus on a given set of workloads or endpoints or pods in Kubernetes. Now, to select those workloads, we could use endpoint labels, as in you could use labels assigned to pods. You could further use namespaces. Let's say if you're using a global network policy, you could further narrow it down to a given set of namespaces or a namespace with a particular label. Or it could even be service accounts. So within a given scope, you could target a set of workloads that have a certain service account. Okay? So you define a scope, and within the scope you use selectors to focus or narrow down on a set of workloads or pods. Okay. So once you've identified the workloads for which you want to apply a policy, we then have a set of ingress and egress rules. Okay. So within an ingress rule, you could further define a subset of those workloads using the destination field. Okay. And you could then define the source from which you intend to permit or deny traffic. Okay. Now, in selecting the source, you have the option of using, again, endpoint selectors, as in labels. You could use namespace selectors, service accounts. You could even reference external networks using what we call network siders or network sets, and we will look at an example of network sets. Okay. Now, a rule can have several actions. For this series, we're going to focus just on the allow and deny actions. Okay. So similar to ingress rules, we also have egress rules, and you use egress rules to permit traffic from the selected endpoints. Okay. So ingress rules are used to permit traffic to the selected endpoints, and egress rules are used to permit traffic from the selected endpoints. Now, in selecting the egress sources, there's a source field, and you could use the same type of selectors to select a subset of sources from the endpoints scoped in the policy. Then you have the to field to define the destination, and you could use the same selectors to define a destination to which you are permitting traffic, and you have the service or the protocol to which you want to permit traffic, and the protocol could be TCP ports, UDP ports, ICMP, SCTP, and even HTTP selectors. Okay. Alright, so I'm going to use one more diagram to drive this home. This is an example. Let's consider three namespaces, namespace blue, green, and yellow. And I'm using selectors. I'm using a scope and a selector to select the workloads in namespace green. So my policy applies to workloads in namespace green. And then you can have ingress rules to permit traffic to those workloads. And if you look at the ingress rule, in this case, for the destination, I've selected a subset. So basically, within that namespace, I'm selecting a subset of workloads with a label D as my destination. And in the case of a source within namespace yellow, I'm further selecting a subset of workloads, as in workloads with a label E. And I'm permitting traffic from these workloads in namespace yellow with label E to the workloads in namespace green with a label D. All right, this is just an example. Okay. Similarly, on the egress side, I'm using egress rules with selectors, and in this case, I'm using a from selector to select the workloads in namespace green with a label C, and I'm permitting traffic to workloads in namespace blue with a label B. Okay. Just another diagram to help you understand the anatomy of a Calico policy. All right. Perfect. So next, let's dive into an environment and let's go through the policy examples. I'll see you in the next video. Thank you.